So there is a chip called the SSM2164, which was made by Analog Devices, and it was a quad voltage-controlled amplifier that could also be used to create voltage-controlled filters and oscillators and other crazy things. It technically went out of production, and then Cool Audio, which I think is a Behringer's chip manufacturer, started to make the V2164 clone. Both those chips had problems with the power supply pins, where I think if one of the voltages came up before the other one, the chip would fry and other kinds of craziness, which is sad because it's a very neat and interesting chip. It has a natural exponential control characteristic, kind of like some of the old SSM2040 or the CEM3320 or other chips like that. But unlike those chips that sort of shared an exponential characteristic throughout the chip, or through at least part of the chip, the four VCAs and the SSM2164 and also the V2164 had their own individual control pins. So it was an interesting little chip. It was current in, current out, unlike a voltage in, current out device like an OTA, but probably higher quality than an OTA, one could say. Fortunately, there's also another player on the scene, this new company, Semiconductor, and they're now making a clone called the SSI2164. So it's supposed to be compatible with the SSM2164, but also solve some of the problems with the 2164, so it's an improved version. In particular, it's supposed to solve the glitch where if one power supply pin comes up before the other, the chip fries and things like that. But the other interesting thing is the data sheets that they created are really fantastic. The 2164 data sheet itself has a lot of cool stuff in it. And here there's this application note that is all kinds of fun, filtery goodness. And so I thought it might be fun to actually try to do an Eagle layout of one of these. And so I found SSM2164. Let's start by laying out, do we want to do this one? So here's your standard pole with feedback. There's another one a little bit later that's almost identical. It adds another op amp that allows... here we go. So this has Q compensation. So this apparently solves some of the problem of the low frequency response dipping as you increase the feedback path, which is the thing that happens in Moog filters and other standard 4-pole with feedback kind of configurations. So we have 1, 2, 3, 4... VCAs. We've got 1, 2, 3, 4 op amps, a couple op amps here. I did something a little unusual with the layout in that if you look at the SSM2164, it is a quad. So I'm going to bring the signal in the upper left, and then I'm going to move it to the 1D. So this is the upper right, and then I'm going to put it to the lower right, and then to the lower left. The other thing that I'm going to do that may seem a little bit strange is instead of using one TL074 to cover each of the op amps here, I'm actually going to use two TL074s. I'm going to use two of the op amps from one TL074 and two of the op amps from another TL074 to try to get those close to the corresponding VCAs, and then we'll use some of the other remaining op amps left over for other purposes. So first let's go create the board and see if I've got this right. So let's take first let me set this up so you can see it. So to bring this down, let me move that up a little bit. A little bit more. We'll call that good enough. All right. So let me take the SSM chip. We'll stick it here just to start out with. Then we'll say, let's take, scratching ear. All right. Then we'll move IC5. And then we'll move IC4, which is the other one. And let's see if the 5 and the 4 relationship, let's see if I got that the way I wanted it. So let's see. So IC4, okay, so this should work out. So the first thing I want to do is I want to place basically the passive parts that have no other option of where to go. So if you look at, for instance, R2, R5, R7, and R11, these only hook to pin 2 as far as chips go. So I'm going to give them priority. So we'll say move R2, rats. Okay. And then I think it was R5 was the other one. Move R7, was it? Yeah, I think it's R7 goes here. And then, was it R10? Yeah, it was R10. Okay, so we put those there. Let's go back and look at the schematic. Let's see what other things are going on here. Okay, now instead of thinking from the point of view of the part, let's think of from the point of view of the SSM chip. So if we look at pins 4, 13, 12, and 5, these can only hook to one passive part, and that's these capacitors and the feedback loop. So let's see what those are. That's C2, C4, C6, C8. So let me move those in. Move C2. Okay. Move C4. We spin forever here. Move C6. Moving C6. Okay. Should be down here. Move C8. Yeah. Okay, so now, wow. Okay, let's put that there. All right, so now you see the flow. The signal is going to come in here in the upper left. It's going to go to the upper right. It's going to go down here to the lower right, and then it's going to go to the lower left. And I already know I'm going to need more space here. And just for fun, since these have different numbers of pins, let me kind of slide that in the middle there, see if that will do something interesting later. Yeah, let's be a little artistic there. All right, let's go back to the schematic and see what else we have. We have, so if you look at pin 14, pin 1, so if you look at the outputs of the op amps, there's a few different options here. So we've got the feedback resistance, and then we have the connection resistance that goes off to the next stage. So what should we do with that? So I think, because we've already got C2 placed coming out of here, let's say that the feedback resistances will connect to the output pins of the op amp. Let's just start there and see what that will do. All right, so that's R3, R6. I may change my mind on this, but let's try this. R3, 6, 9, 12. Okay, let's move R3. And I said I was going to put these with the op amps. Wait, is this not doing what I think it's doing? Let's double check that. R3 should connect to a pin 14 on D. Okay. Oh, maybe I was removing the wrong resistor. Why doesn't it want to... Oh, I had it, sorry, needs to go over here. Although, wait a minute, I don't want it. I think I need to do a gate swap. I didn't get it right over on this side. Let's see. So the input, wait a minute. Did I get these right? Maybe I want to put R4 over here and R5 over here. May have had that all going the wrong direction. Okay. This feels better now. Okay. So, sorry, I had those on the wrong side. So I'll stick this guy here. And what was it? R6. Okay. There we go. And then R9. All right. And then R12, I think it was, connects down here. Okay. Now let's see. Do I still have the same sort of row relationship there? I think I do. What about over here? Yep. Okay. If I did want to have this kind of down like that, yeah. So these are slightly offset to each other for fun. Okay. Let me move this in here. Let me move this in here. Come back here. All right. So that's sort of the basic structure. What are the other resistors that I need to worry about here? There's the R1. These connect the various stages. R1, R4, R7, R10, R13. Let me do the inner ones first. R4, R7, R10. So I've got move R4. Let's see, because it connects. Oh, okay. Let me put it over here because it's connecting from one thing to another. So I don't know. Maybe let's put it here for now. I'll give it some more space. So here's R4. And then was it R7? So that's connecting these two stages here. And so let me put it sideways here just to emphasize that for fun. Probably will change that later. R11 is another connector back this direction. See, that's not quite, because it should be connecting these sides here. Oh no, it's not R11, it's R10. I just completely messed up R11. So let me go back, undo until R11 goes back to where it was. Oh, have I not put in R11 yet? Oh, let me redo whatever I just did. Okay, that probably went in there. R11, whoop. Oh, maybe I haven't put in R11 yet. Let's go back here. So R11 was one of these downward resistors. So 2, 5, 8, and 11. Show R2. Show R5. Show R8. And show R11. Oh, okay. So I think I got these wrong. If I really wanted... Oh, maybe I just never placed it. Right. If this guy's R10, then really R11 that hooks the cap. That should go here. I'd messed that up earlier. Sorry. Okay. So now R10 is this connecting resistor. All right. I like that. Let's go back to the schematic. And then I've got input-output resistors. I've got R1 and R15. So let's move R1. So this is the initial input. Now, I'm probably not going to leave it up like this. I'll almost certainly turn it horizontally at some point. But I just want to remember that this guy is input. So I want to call him out. So I'm setting him vertically for that. And then if we go over this side, we've got R13. So let me do R13. Move R13. So he's the output. Again, I'll put it like this to remember that's his output. Again, I'm almost certainly going to turn him sideways. But I just want to put it now to get a sense there. All right, so let's see what else we have. We have these capacitors that come out of these resistors that hook to ground. So that's C1357. Move C1. I'm going to put just here for now. I'll probably turn them. R3. Move, not C3, I mean. C5. Okay. And then we'll move C7. Yeah. Okay, so there's C7. Rats. So now you see this has a nice structure. There's a nice symmetry going on, which I wouldn't have if I just used a single TLO74 for all of the output op amps for the VCAs. All right. So with that in mind, let's see what else we have in the original circuit, the original schematic. So if I pull up the data sheet, so there's two op amps that form the feedback path. This is the main 4-pole with feedback structure. You always see this. This is a little one that's thrown in for the, what do they call this? Q compensation. It also tends to shift the peak, but whatever. Basically, if we put this op amp in, what that will do is it will essentially help compensate for the fact that under the standard structure, low frequencies will be lowered. This will boost those back up the way the overall structure works. Okay. Need some coffee or to go to bed, one of the two. It's 10:46 p.m. All right, so now you'll see one of the reasons I chose this particular layout. Since if I have the input here and the output here, it's going to be very natural to use the op amps over here for the kinds of activities that need to be happening with input and the output. In particular, let's see, if I go back to the schematic, where did you go? Ah, yes, there you are. Okay, so this one comes from the output. So for the output, that's the lower left one. That's the lower left VCA. So let's put that there. So if I go back to the board here, so here's the output. So that would be op amp IC4B. Let's go see if we can find IC4B somewhere here. Do I need to invoke it? Probably need to invoke it. So I'm going to say invoke IC. Ah, here it is. Oh, I think it was already on there. Anyway, let me flip this around. Do we have... Right. So that will be coming from the output. Let's take this down here. IC4B. Whoop. Let me see what we do with it. It goes from the output through a 10K resistor to that op amp. Okay. And then I'll probably do that without making all of you watch me do that. And the input, so that's in the upper left. So for that, I'll use 4A. Yeah, let's go get that. So move 4A. Here it is. The way they like to set that up. And the way I like to set up too is the positive is downward, negative is upward. Okay, so I'm going to stop the video here and wire up the rest of this, and then we'll work on the PCB some more. All right, so I went away for a bit and I added things to the schematic, all of the various feedback loop parts in here. I also fixed some values that were wrong, and one thing I did want to point out is this resistor, I just randomly called it R130. I'll change that to something else later. This is a protection for the output in case somebody accidentally takes the output here and shorts it against a grounded control panel or something. This wasn't in the original schematic. All right, so with that in mind, let's now see what I screwed up in trying to make the board layout. Okay, so here's the board layout with the various items that I added. And the main thing I want to do is to see where this R13. So R13 we'll put into pin 6 of IC4B. So move R13. I think I just called it. Okay, so that's the output. And it wants to go to, it wants to go to pin 6 here. Oh, we might wind up doing something like that. We'll see how this goes. Okay, let me put this here for a second. And then what do we have in the feedback loop? Or actually, what do we have coming out? So we have coming out, it has R15. So we'll put that in pin 7. Move R15, goes to pin 7. Okay, let's see what we did that for a second. And then go back to the schematic. We have a resonance pot here. Let's move resin. Okay, this is something that we'll typically want to have near the edge of the board. So we'll put that here temporarily. And this isn't the kind of thing I wanted to use for that. I wanted to use a different part for that. Let's see, because this resonance pot here, that's a front panel control pot. So let me see if I can rename that. No, not rename, replace. Replace is what I want. So looking at my little cheat sheet, I usually use trim _US _B64Y. Yeah, that's what I want. Let's see if I can do that. Click. Did it do that replacement? Just go back to the board. It did. All right. So let's stick that down here for now, because that will be some sort of control pot for the front. What about IC4A? Okay, so the output here, let's make that R19 for pin 1. Move R19. Okay, so we'll put this here. Let's see. And then the feedback loop, I've got... Actually, this is a connector. For the feedback loop, let's actually use... Well, I've got two places I could fit things in here. So R19 is actually a connector resistor. So maybe what I'll do with R19 is I'll put that elsewhere. It'll be something like here, just temporarily. Stay there. All right. Let's put in the feedback loop. Let's put R16. So I'll have that come out of 1. Move R16. Right. Okay, that feels good. What about R14? That's also connecting to the input. So move R14. Okay. We'll start with maybe something like here, just to get going. And what else do I have down further here? Not sure I'm happy with any of the placements I just made, but doesn't really matter for now. Let's see. Okay, this junction of R17. Oh, R17. That's sort of connecting these two sides also. So let's move R17. Oh, no, I already did R17. Okay, R17's already there. We've got this resonance limit pot, and we've got the diodes. Let's see. Whoop, I'm sorry. What happens if we move D1? What do you want to connect to? Okay, sure. I'll stick you there for now. What about D2? Okay. Now, one thing we might want to do is actually something like this to have them both going the same direction. Or we could have them both going different directions. I think whoever's putting this together is smart enough to figure that out. Sometimes you want to try to have things running the same direction. What about Q1 and Q2? Move Q1. Move Q2. Okay, those look kind of nice. Whoop. Those look kind of nice together. So let's zoom in here. Oh, sure. Okay, let's go with that for now. And what else did we have? We have R18 and reslim. Move R18. Okay, maybe I'll stick that here. And move reslim. Now this should in fact be a trim pot. Now let's just stick it over here for now. I'm not particularly happy with the way this is all spread out, but we'll fix these things in a second. All right. Now I had some dual op amps in the original design. Let me just go in and get rid of those to avoid cluttering up my brain here. Where did you go? Here's TL072 things. Let's get rid of those. And, oh, you know what? I should hook up power. So eventually I'll set this up. This is part of my template to take either Euro or MOTM style connection. So we'll set this up to use either ±15 or ±12. the meantime, let's power up the chips and also put in some bypass capacitors. So I'll use invoke to get the power supply for my... Oh, that looks different than everybody else. It's kind of awkward looking. But, okay, well, we'll set that over to the side here. And then we'll invoke to get the power pins on my op amps. I've got power. Let's also invoke for number 5 to get the power. And let's put in the necessary bypass capacitors. So the bypass capacitors, do-do-do, do-do-do, do-do-do. Oh, you know what? I should have changed the value here. These are going to be 0.1 microfarad, and I'm using a convention of putting the U for micro in for the decimal point so that it doesn't get lost if this is printed on a junky printer or something. So we'll say OU1, OU1, OU1. What do I want to call these capacitors? Actually, let me name them something to try to get them outside of the range of the other things I might be doing later. So let's call this 50, and we'll call this 52, and we'll call this 54, and then I'll copy doot, 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 doot. All right, so actually let me put the power pins on the other side. So group these, move them over, squish them. Yeah, and let's name this one C51, C50, nope, C53, C55. So we have odds are going to hook to the positive and, no, odds are hooking to the negative and evens are hooking to the positive. Nut this all up. Put in the power supply pins here for the op amps. Now I may want to put in some other parts later, so maybe I'll leave a little space there if we need to put in more bypass caps. Okay, so positive power to op amps should be hooked up. Yes, merge those. Thank you. Now I'm going to take the positive mark here, and because there is this pin 1, is this weird mode pin. Let's copy the negative supply pin. So everybody here should now have a negative supply. Let's also copy a ground because this chip wants a ground. The mode pin we'll go back look at later to see what we should be doing with the mode pin on the data sheet. Okay, so let me place bypass caps. I actually should have done that earlier. So move C50. And let's say we'll center this. Oh, we'll just go left to right. Okay, so IC4, let's see, where's the power over? Okay, positive power is on the left. Then move C51. Forget, yeah, these are, so I'm always typing rats to figure out what's hooking to what. Let me do show ground just to illustrate that. Okay, these bypass caps need to have grounds hooked up too. Well, let me just place them first, and then I'll go do that. Move C52. Let's see. Now, I think the power for this chip is all on the same side. Yeah, move C53. Right. Okay. Now move C54. That will want to go over here. Power this guy. Move C55. Okay. We'll put them there for now. Okay, show V plus. Those are okay. Show V minus. Okay. Now let's go over here. These should be hooked to ground. So let me, merge that to ground. You always want to merge unless you don't. All right. So now if I go over the schematic and I say show ground, those things show up. Okay. Now, I am going to have to supply some sort of control current. No, I guess it would be control voltage because of the way the VCAs into the 2161 work. And so for that, we're going to have to, don't think they have an example. I think it's the data sheet. So this is the app note with the filter ideas. It's the data sheet that has the control voltage circuitry example. So I'm going to pause here and go get that. Okay, so off-screen recording, I looked up the SSI 2164 datasheet, which is different than the app note that we were adapting the schematic from, the main filter itself. I went back to the datasheet and found this nice generic control voltage driver specifically for driving, I guess, either an oscillator or, in this case, the filter cutoff, a volt per octave response. So I adapted two of these and then I added a third, one to give another sort of a controllable modulation input. Now, we're going to be running either minus 12 or minus 15. So what I'm going to do, instead of trying to put in a voltage regulator for minus 10, if we go over to Eagle and take a look at what I did on the schematic, that's not the schematic, this is the schematic. I put a resistor here. So this can be either, let's say, it's going to depend on what we're using. Okay, not the name. Let's use value. Value, so I'm using a 10K pot. So we'll use either 51K or 2.2K, say, because those are common values. Depending on if I should really just make this a C note. Let's see. Right, so because this is a choice. So what I want to say to indicate that we'll just say C. Oh no, it doesn't want to have a space there. Well, you know what? I'm just going to leave it like this, the 5.1K, 2.2, and then we'll add a note on the PCB. Actually, let's add a note right here. So where's my text tool? There's my text tool. So I'll say use R99 should be 5.1K for plus minus for a minus 15 volt power supply and 2.2K for a minus 12 volt power supply. Okay, so we'll put that in here to indicate which one we should choose. Now, this isn't going to be a perfect divider because this will load it down a little bit, but we've got 10K plus or minus going into 100K, so that it's going to be pretty close to being able to morph between 0 and minus 10 volts per what's on the data sheet. So here's the volt per octave input that was already there. And the main thing I added, if you take a look down here, I added a thing I called a modulation in, and then I had a control called modulation amount. So this is another, you might, you probably would put your keyboard control voltage in here. You sort of set a base level here with this pitch control. And then you'd use this to control the amount of, say, how much of an LFO is affecting it or something like that. And I think that would be good enough. If you had an envelope and an LFO or whatever, you could use a mixer and some other module or something. I did a bunch of other cleanup. The other main thing I thought would be interesting, so we have a summing node here, and I added this, what I call QCOM, for the Q compensation control. So if you turn this all the way up, then it would do the Q compensation of the original circuit I showed you. If you turn this all the way down, we've got ground, nothing's going in here, and that would shut it off. So this is intended to be a front panel control, and I thought it would be interesting to give the musician a way to dial in between those two different modes. All right, so the other thing I should mention, instead of running wires everywhere, I just named these bus wires coming out of the voltage control input. I named these FC, and so that matches the FC over here. So that pretty much matches what's shown on, wait, that's not the data sheet. Where's the data sheet? Here's the data sheet, the FC notation on this schematic. All right, so now that I have those things in there, let's figure out what we want to do with the circuit board here. There's a whole bunch of stuff in the feedback loop, isn't there? Okay, well, let's place the diodes first. Yeah, let's have the diode coming out of 14. So I'm going to move D4. I decided to use this op amp up here. Okay, so we'll have that there. Let's move D3 just to kind of match up with it. No, I want to rotate that. Yeah, these are going different directions, but I think that's fine. We'll assume that the builder is smart. Chips, I really do like to have all the vertically going chips going one way and all the horizontally chips going another way. Even if turning one of them around makes the layout easier, it just lowers probability of somebody screwing up. But when people are putting in diodes, they seem to pay attention. So we also have R300 and C100. Move R300. That go, oh, this does go here, so maybe that, R300. And let's move R100. Well, these are in parallel, so they should be. Something does not feel right about that, because if we go over to the schematic, those are in parallel. Why do they not look like they're in parallel? R300, R100. Let's zoom in here. Show R300. Show. Oh, no. C100. I did the wrong one. Let me. What does. Okay, I was moving the wrong things in here. So what is R100 is part of my mixer network. I want to move C100. That should show up as something parallel to this, right? And it does. Okay, if I do something like this. Makes it clear it's not trying to connect to that pin is what I'm going for here. Oh wait, no, but it is though, right? It is good though. So I can go ahead and, I'm going to go ahead and scoot him up like that. Now, I don't want them to connect here, because that's a ground. Is that a ground? What is that doing? No, that's going through the diode. How do I want to... Okay, I may come back and think about how I want to wire all that. Now, the inputs, I've got the R100, right? I've got... Am I going to use this other op amp? I'm probably not. So maybe I'll just put them here. R100, R101, R102, which is the remaining things. And then I've got my controls here. So I'll move the, I think it's 1 volt per octave. What did I call that? Or maybe it's move volt per octave. Yeah. Okay. It's this guy here. Then I've got the modulation amount pot. Maybe I'll stick them here. We'll see what we want to do later. Move modulation input, modulation in. Okay. Maybe we'll put that here, something like that. Do I like that? I think I like that. What if we did it like this? Then those grounds go together nicely. Okay, whatever it is, whatever's we're going to do. We're going to do something. How about this? Okay, anyway, we'll stick with that for now. And let's do some rat's nesting. Go back, go back, go back. What other parts do we have here? Oh, there's the Q control. I thought what did I call that? Q compensation. It's the amount of Q compensation. Okay. Move Q com. Where does it want to go? It wants to go somewhere up here. Okay. Possibly. Then we also have R17. Oh, the pitch control. Right. R19, R17. Oh, what is R17? R17 Oh, did I never actually put him in? Okay. So move R17 wants to go probably up here somewhere. Oh, it's related to this guy here. Show, yep, all of that network there. And then let's move the pitch control. So we're going to move pitch. Pitch is up here somewhere. And there's an R99 associated with that. Okay. That's also part of going to that network up here. Oh, wait, no, that's going to a negative. No, that's just coming straight in here. Right, okay, they can just live there. That's fine. That's the thing that's going to one of the supply voltages. Okay, so let me start to think about how I want this to actually put the power in. So that I'm going to think for a second, and let me go get rid of all the stuff from the, say, I don't think I really want one of these test points. I'll get rid of this, get rid of this. Those are from sort of my template. Now, do I have any template stuff left? Don't think so. So how do I want to run the power on this guy? Oh, wait, I do have, what are you folks? You're the audio input and output. Yeah, so let's figure out where you want to go. Your audio in and your audio out. So you are probably coming up down here somewhere. Yeah, that's what you're doing. Okay. Now this could certainly compact more at some point. Now I want to stop for a second and think about where I want to put the power. So to get a sense for that, let me just look at where the grounds are. Okay, they're kind of all over. That's what I was expecting. Now let's ask for where who wants positive. So positive goes here, here, here. Show negative goes here, down here, down here. Let me think about that. Hi, so okay, this is a time skip of many, many hours. I made a pretty serious strategic error. I started with a board that was way too big. It was somewhere around 6 inches this way, going this direction, and I wanted something that would fit with this going vertically in a Eurorack format. So did a lot of changes here and wound up, okay, so that's 3.75 inches. And how deep is this? This is 2.2 inches. Okay, so if this is running 90-degree angles to the front panel, this I think would still fit in a lot of desktop size skiffs. Maybe not all, but a lot of them. The other thing is I wanted to build this with both an MOTM style and a Eurorack style connectors for plus 15, minus 15, and plus 12 and minus 12 volt fans. And when I originally had it like this, I was like, okay, well, I'll put it here and everything will be nice. But that got awkward. And I didn't want to have a single set of bypass caps, etc. for that would be too far from one of them. So I wound up just saying, okay, over the schematic, I just duplicated everything. And I'll tell the builder, you either will build out the C's, C48, 49, and L1, L2 that end with an E for Eurorack, and you'll leave the M stuff blank. Or if you're doing MOTM, okay, so this should be L2M, right? And while I'm at it, let me give these a value of bead to indicate that these are fair. Oh, nope. So value. Oh, wait, no, I think I do. I just need to move them around. So we'll say that these are beads, right? Move those in a second. Bead, 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 bead. All right, so this is a bead. This is a bead. This is a bead. This is a bead. All right, so those are ferrite beads. That's a trick I picked up from Paul Schreiber of MOTM. So you don't build the beads and the capacitors for both of these. You just pick one, whichever one you're doing. And I think that worked out okay. So the main thing I wound up having to do is I grabbed all the stuff that was on the right hand of the board and I started scooshing it left. And to do that, I sort of started jiggling things around here too, like the bypass caps for the chips. I wound up turning sideways, trying to scoosh that in. All of the stuff that was over here, I had this beautiful structure coming out. I had to take all of that and either fold it this direction or down this direction. And let's see what kind of hash I made of things. So what I like to do, let's start with laying out a ground rail. I'm going to start with 32. You know what? I'm going to go with 30. Just to... Nah, 32 is the default. Let's go with 32. Okay, so we have a lot of grounds that we need to hook up. And this goes, these all hook up, these all hook up, these all go across. And what I want to do is create basically a set of kind of fingers that go out this direction and run around. I want to make that go a little bit further out. Here, pull this in a bit. Yeah, I think that'll be okay. And going up to here. And okay, stop there. Stop. Stop. So let me use rip up, tidy that up a bit. Okay. And I know that it's going to have to touch here, but before let me go ahead and just kind of get the overall ground structure that I want. So let's show ground again. Okay, so there's going to be one. Can I move my resonance pot here in a bit? It can if I move these diodes in. Okay, I like that. Okay, who wanted a ground over here? You wanted, nope. Route air wire, indeed. Yes, that's the thing I want to do. I want to route the air wire. So I'll grab this here. Come up here, something like that. Come around this side. Maybe I could scooch that. Let me scooch this in. Nah, I'll go ahead and make it symmetric with the other side. Just keep it consistent all the way through. And this is going to come up through here like this. Okay, so now I have these sort of fingers. Now I don't want to have this go all the way around so it creates a ground loop. That will cause sadness. Okay, let's check out what's happening with the power. Let's show V+. Who wants power? Do the same thing. And what I'm going to do is I like to route power off the top. Now, okay, I think this will work okay. So we'll route power from the bead. This is coming from the here. Okay, now this is going to go... Oh, wait, no, I want to turn this around. Flip. There you go. Whoop, nope. All right, so let's try routing that again. Route air wire. Coming out here, routing down there. Okay, and coming out there, routing up here. Okay, that's legit. What about the beads up here? Okay. Okay, like that. I want to get some more clearance between that and the ground. So let's route it like that. I want to leave some space in there. Okay. Same thing here. Okay. So those are from the power to the beads. Show the ground here. So if the user... Okay, I do want to make sure these grounds are connected. Nope. Let's use our green. Not green. What color is that? That's the color blue. Yay, very exciting. Okay, so if the... Right. Because I have to set this up for either... Oh, that's kind of... Okay, so if... It's going to go through here. It's going to go up through here, over through here, down through here if you're using the Eurorack. Do I like that? I guess it's okay. It's no rule. Okay, it'll be kind of like running a wire this way, whatever. And I don't think, you know what, I can pull this guy in quite a bit because I'm not going to get anywhere near up there. All right, and oh, you know what? Let's spin this Q control around while I'm at it. So let's rat's nest that. No, okay, this is a little silly. Mr. Ground, you can get a nice connection here. Why do you want to connect all the way up there? That's a very strange thing for you to do. What do you want to do? Why do you want to do that? Okay, you should be happy now. Show ground. Those are all grounds. That's kind of strange. Why was it wanting to do that? Did I used to do? Nah, it should be good. All right. There's... Okay, I want to make sure... Let me zoom in on this, because whenever I'm dealing with things that are off-grid, I want to be very careful about how I come out of them. And I'm doing things that if you were 100% sure you're going to make this board with a professional board house, would not, be a problem to have these tight spacings. But in case somebody, maybe they have their new CNC machine and they want to test out. So is that a ground? But it wants to, these need to actually connect to, I'm philosophizing about this wrong. This is my big bypass ground. So it should go here. And this should go here. And the reason I'm leaving this extra little space is in case somebody, they've got their really fancy, if you're building this out, it means that you are using the Eurorack. So I'll put you over here like this. If somebody has a CNC machine, do it DIY kind of thing, or if they're using a photoresist, photo etch method, whatever that is. Okay, the easiest way to get this ground here is to go ahead and come out from the cap. There we go. I like that. Yeah, let's go ahead and do that. There's no, if you really wanted to go star grounding. No, it runs right there anyway. Okay, why am I being so pedantic? Okay, so we'll run this around here. Or maybe, whatever technique you have to make PCBs, if you're not getting it professionally made, it helps to have a little bit of extra clearance. A little extra clearance. Okay. Why did that... Feels like it's not matching up as exact as it should, but I'm probably just imagining things. Okay. So... Oh, you know what? Because I bet you later it's going to want me to connect these V pluses. Well, it should connect somewhere else further downstream. All right. Okay, so I have the main sort of filtering of the power coming into the board. Okay, once I have that, let's see how things cross. I bet you I can run here. Okay, let me go in a little bit. Because I want to zoom in here. No. Did I change something? I hope I didn't change something. Oh, wrong thing. Okay. Zoom select. Okay, so let's see who wants pluses here. So if we're coming out for either standard. Okay, so MOTM, I think, we could run this guy here. We'll have to probably run the negative supplies back, through a more circuitous route. And I think that feels a little tight to me for the way I like to do things here. So let's go here, pop out, get some clearance, and okay. So we'll do something like that. Okay, that gives us a V plus there. Now, who else needs a positive supply? There's a lot of crisscrossing going on in here. That's a little scary. So let's see what else we can do here. Okay. So let's say that Okay, what if you're using Eurorack? If you're using Eurorack, you'll come through the other direction here. All right. Right, and now it should be happy that my Eurorack and MOTMs are connected again. You should only build out one of these. Show V+. Right, okay. So there's so much crisscrossing going on there. I think I'm going to need some red. I'm going to need to probably combine some red and blue to get all of that connected up. So what I'm going to do here. Okay. Oh, turn off all this stuff. There's all this run around things that just confuses things. All right, so if we put this up here, I'm going to use so I have my grid set to sort of halfway spacing that I'll use some time if I want to make sure I'm getting around some potentially tight spots. And sure, let's pull this off of, let's go ahead and pull it off of the B. The bypass is going back the other direction, whatever. Okay, so those are V pluses. And I did this because I think I'm going to need some combinations of reds and blues to handle this tangle. Let's back out, show V plus. Oh, the only other place I need on there is to the bypass cap. Yeah, so let's just route that. That's fine. All right. Okay, so I've got all the places that need V plus have been wired. What about V minus? Okay. Let's start on the right because that's easy. V minus over here. Okay. Right. I think, can I run these together? Yeah. I'll just run another. There may be some, I think this should be okay. Let's zoom in here. Okay, so we have the supplies coming down like that. All right. Show V minus, more or less. I think that will work. If need be, I could actually run this. I could run this direction on top of the ground trace. I occasionally don't like to do it that big. You know, it would be fine. They're on two different sides of the board, but it can later become hard to follow what's going on. So I'm actually going to do something a little bit strange, which is let's forget the power supplies for a second. Switch to 16, which I like to do for a signal. Let's start doing some routing over here, see what we need. Okay. If this goes up here, I think that's fine. This, if I wanted to. Oh, you know what? How about this? What I'll do is I'll just go ahead and say, whoop, I made this over really complicated. Oh, no. Okay, just switch that to the top layer. Switch this also to the top layer. And I can come over here and grab this blue. Okay. And then, yeah, I'll run it over here. I'm going to use that in-between setting. Oh, I don't even need to do that, right? It's just because it connects. Oh, no. Right, it does have to go along there. Okay, is that something I actually wanted to do? No. Okay, I'll probably come back and think about this later. What if I did run the red outside? So what I'm going to do is I'm going to rip up this trace here and run the power. Here goes, nope, wrong color. Let's do here. Yeah. Oh, this is interesting. It started to complain at me. Why didn't it complain at me for the blue? Anyway. Okay, so it goes here, it gets bypassed, and then it goes in. Right. Okay, so show V minus like that. And then you could poke this up different ways. Okay, now that I have that, oh, I still have the blue going over here, right? There is a blue that wants to cross this little zone here. Wait a minute. I'm making that overly complicated. This isn't even a signal. Sorry, that was embarrassing. Right. Okay. So what I can do here, right? This is a ground. That's not. Okay. So this is a ground wanted for, right. Okay. So these are grounds. Doesn't have to go over here at all. Oh, come on, Letterman. All right. So now that now that I know what I'm doing here, right? Because we can have ground snake around through other means. Okay. Right. So that's a signal. And we've got. Let's go ahead and route some signals here. This guy is going up here. Is that an input or an output? I think that's an input. Anyway, let's do something like that because this is an input pin. Where do we... Oh, well, if it's coming from... It's actually coming from out here. So actually, let's just... So the only reason I'm doing this is I like to be able to sort of look at the way the whatever's angle and get a sense of the signal flow. So I know this is coming in from some source. Okay. So I've got route. Okay, that was kind of fun. Okay, we'll come back and think about what to do with the grounds and such. Okay. Well, let's do some grounds. Let's just go ahead and do it. No, not whatever that was. What did I want to do? Oh, I wanted to change the 36. Okay, show ground. Who wants grounds? This guy here, clearly. No, this layer is what I want. Okay, he wants a ground, sure. You would like a ground? Sorry, allergies. And why is it? What are you doing there? Silly thing. Why are you complaining about being too close to the edge? I'm not actually going that close to the edge. Let me pull this in. Don't know why it was so fussy. Okay. So ground here. Ground here. Oh, that's the signal. That's why it was fussing at me. Okay. This is the ground. This is the ground. Don't know why I'm being pedantic about this. I don't know. I just like angly curving things. Show ground. Okay, that makes sense now. And we'll have as the limit sort of over here for now. Now again, why are you doing that? Why are you unhappy? That's strange. It keeps showing those complaints there. Okay. Now, that was a bit of a side jaunt. And why am I not using the auto router? The main reason is that you may come up with a better layout of parts that you won't notice if you use the auto router. The other thing is the auto router tends to pull things in very tight according to some algorithm, but I like to have the traces be as much as I can, something where when I look at the board, when I'm trying to debug it, I can follow what's going on. That doesn't mean I don't use vias, but I and I'll absolutely use vias if I think it will give me a clearer, cleaner layout that I'm not going to Timbuktu and back. But if you have a bunch of vias that you're constantly crisscrossing on either side of the board, it can make it hard to follow what's going on. And if you spread out the traces a bit, it means that if you need to hack the board later, if you need to start taking an X-Acto knife to it or scraping off, heaven forbid, scraping off some solder mask to make a pad to try to solder bodge wire to, if it comes to that, you'll have some clearance. You have some space to do that. Okay, so that had everything. Who needs a negative supply? Okay, so we need a negative supply over here. How should we do this? Okay, I've pretty much committed. Okay, for the negative supply, let's run backwards because we're going to need blue to connect things in here. So let me zoom in. I'm going to say, no, I want to use red. Okay, so V minus. Well, one way or another, we are going to need to connect our different styles of grounding here. So maybe, okay, let's live dangerously a little. What if we said just to cross here? Actually, no, because that's where the power is. That's where it needs to be. Okay. But it is really appealing to just run the negative around this way. Okay, so let's do that. So I'm going to pull out here. Let me zoom in. Let's see what we're doing here. Pull out here a bit and go like that. Okay, and okay, how are these things going to want to cross? Let's assume that we'll cross. I'm going to use my middle here. Cross there. I kind of like that. Okay. And then we'll run up here. All right. And then we need to, no, show V minus. Okay, we need to go over here. What I'm going to do is I'm actually going to make that little segment later so I can grab this segment and say, hey, I want to zoom around here. And what I'd like to do, actually, is I'm going to move this guy over a bit. Sure, let's put him here because I want to get some space to maneuver around. Okay, I'm going to click here. Space here. Okay, so this is tight. This is usually tighter than I like to, but we'll assume that we're doing something reasonable here. And am I going to need some other wires? I don't think so. I think the way this thing is structured. So let's go here. Let's go up here, here, and like that. Okay, so this is a little tighter than I usually like to make it, but it'll be fine. All right. So now I can actually wire this guy through here. Let me back up. Show V minus. All right. Zoom in. Show ground. Or show V plus. First of all, did I miss anything? I don't think so. Now let's do a show of V minus. And the thing I need to do is actually get these two connected. Okay, so this is a little awkward. How about for the segments in here, let me switch those to blue. So I'm going to say info, make you, why are you being so whatever, info, bottom. There's probably, I'm sure there's a way to select all this and do the entire trace at once. I just kind of never got around to, whoop, what are you doing there? Gah, info, probably be quicker just to rerun it. Actually, let me do that. Down. So I'm just going to rerun this, rip up that via. Okay, so I'm going to get a bottom trace here, size 32, and just connect those like this. Connecting some traces because it's so much fun. And do the same thing here. Okay, so I'm going to connect this trace using blue. All right. And now, if I look at the V minus that wants to connect up, oh, it's going to want to connect up here. Okay. Now, to fake this thing out, what I'm going to do is I'm just going to ahead and rip this up and rerun it. All right. So I can have a, going to use my in-between setting here. Because that is tight. Oh, that is tight. That is much tighter than I like. All right, and if we're building the MOTM version, then let's just go straight here because we won't be using that bypass setup. Does that make me sad? I think that's okay. What if I moved Skype just back a bit? And there, just for the sake of symmetry, I want to leave some space here in case somebody's using one of those fancy shrouded headers. I have no idea why Dieter Dofer thought it was a good idea to have these non-polarized headers. It was a really terrible idea that now we're stuck with. And I guess if we're hooking things over here too, we're actually not, it's not that bad. Okay, now that I think about it, because you're either building this or that, right? So you don't have to worry about things getting shorted out one way or another. But okay, I like those there. We'll leave those there. Right, because you're only building one of these setups, so that should even if there's a little something here is a little more shorted than it should be. I don't think it would be a tremendous whole lot of a problem. Okay. Now, did I catch everything there? Right, because if we are hooking this up, we're not installing this and vice versa. And this should still go because this is going to be a plated through hole. Everything should still work even if you don't install a part there. All right. So with that in mind, okay, we have 93 hair wires to go, which is fine. The main thing I want to go is all of the V minus connected. Okay, and all of the V pluses. All right. So the next thing is let's start doing some signals. And I tend to like to do that using blue, just so if I'm looking at the back of the board, I've got most of it on there. And let's start with low-hanging fruit. So things like, oh, you know what? Yeah, no, let's do some of that, and then we'll go back to doing ground. So this is going to be 16, like this here. Just stuff to make ourselves feel good about various signals in our circuit. So like this output here, it's also going to run this output. So the edge pins of this are an output. So notice I have it fanning out from the output. Again, it does not really matter here. But I like to, for the sake of... see, now we can start to see what we can do by placing different things. Like, let's see what ground... Oh, but this needs to be here. That is part of that. So, although this, right, it does need to connect to that. But I can, if I push it out over here, it should have a little easier time of it. We'll connect this guy through here. All right. This guy here. Make sure those are grounds. Aren't grounds, right? Okay, so this is I have no idea if this is an input or an output. What goes on? If it's the 15K, I think it's an input. Right, yeah. So it comes from, 15K is an input. So this is something going into an input here. Sure, like that. And then, it looks like it's also going, maybe there's two things that are mixed. I think this is going around Oh, because I think, I forget. Anyway, we'll call this close enough to figure out there's, how you want to wire this up. There's 100 different ways and they're all valid. I just sometimes do like to try to have some sort of logic in how things are running. And what is this guy I want to go to? So put a little clearance here. Have them come out down here like that. What does this guy want to do? He goes here. He's probably some sort of input. We'll put him in here. Are you grounds? Nope. Okay, I want to make sure you're not grounds. You're whatever's you are's. Whatever you are's. Nope. Okay, that's wired as a virtual something or the other. Okay, so transistors are dodgy. These can be hard to solder and get working, everything. So notice I'm making a big deal about coming out of the sides of these things. Okay. And this, because of the way this is set up, can I change the role of these? No, don't do that. I want to just grab the part. And then I'm going to take this one up here. So see, I found a rearrangement that was a little bit more elegant, and that's fine. So notice I'm coming out diagonally. I'm not going to come out sideways just because that's awfully close. Again, if you're using some sort of homemade doodery-dad. But I could tighten this up. Not that close. I like that. Okay, that works. That makes me happy. And this one's very tricky. So I'm going to have it. I'm going to use my... okay. I'm just going to cross my fingers. Okay. We'll assume that the process is good enough to handle that. All right. Okay, so a lot of the other things that we need here are grounds, but it's not where... let's do some more signals. I feel like doing some more signals. All right, so you're a signal. Great. You come in here. Okay. No. Stop that. Signal. So this is a input. And what's going to the input? Some sort of... let me go... I'm going to go up one here using my halfway in between thing. Okay, something like that. These things are getting mixed. All right, what else do I have here? Oh. How do I want to do that? Okay, let's say if I came out from here, there, and then I went down like that. Yeah, let's do that. Because I'm not sure why I did it that way, but I did it that way. So, I can now run a trace through here. We can do that. We can run between the pins and run up here. Oh, no, it doesn't connect up here. It wants to connect way up there. Right? Oh, that's fine. Oh, let's go ahead and hook a signal in here. Hello, signal. Okay. Okay, so this is going to be a little tight. To make this less tight, I'm going to move that guy there. Right. Okay, I'm actually going to run this coming from the other direction just to see how it feels. And I could probably make this red and get a lot more direct, but I don't think there's a huge advantage in doing so. So I'm going to come up here. Okay, how about that? And then this guy goes here. And I am going to have to do some red in here. Now, what I might want to do is kind of the main thing we're doing here. Let's look at the grounds. Okay, some grounds are going to go in here. So let me actually back out a bit and start doing some grounds. Let me back out. Let's show ground. So I'm going to switch this now to 32 and see who wants ground. Whoop. Come back here. There we go. Okay, who wants grounds? Oh, so this guy here wanted a ground, but it is awfully tight. So we'll go ahead and use a smaller one there. But let's see. No, I said I wanted grounds. So I'm gonna actually this is usually a little dicey, but I can figure it out. I'm gonna actually just directly draw a line, not with red. Instead of using the click on an air wire, I'm going to, oh boy, it doesn't. Okay, now if I do this like this, will it figure out? No, because it wants to hook it in here. Okay, here's how I'm going to fake it out. I'm going to actually rip up this guy. And now I'll be able to click on this air wire. Sometimes that works, sometimes it doesn't. I have no idea what the logic or not is. Nope. Okay. Yeah. Okay, that looks good. We can even tighten this up slightly. Right, okay. And now, okay, this is getting dicey to get in there. So here going in, we'll go ahead and use the smaller width, which is fine. It's fine. None of these are huge impedance. I said I was going to use the smaller width. But I like to use the larger one, the larger traces for ground and power, just sort of as a visual indication when I'm looking at the board. And if I want to make this even a little more clever, let me move this one in so that this guy wants a ground. You can go ahead and be the full width here. Let's go ahead and we'll have a branch off of there. That's kind of nice. All right, who else wants grounds in here? Okay, they got grounds. So you want a ground. So come down here. Why is that? Oh, okay. You didn't need to actually go down that far. That's fine. All right. I think somebody else in here was wanting a ground. This guy. This guy wants a ground. So, what I'll do here is put this guy here. I'd like to have a little more clearance there. So I'm just going to move this guy not that far over. I'll move this guy. Nah, I don't know. Okay. There's no reason for me to be like so detailed about this. It's really absurd. So let me rip up this guy because I have another idea. What I'm going to do is just for this little spot, I'm going to change this guy to red. Nope. Notice as I'm changing things to red here, it winds up getting rid of the vias as I go, or it puts in a new via when needed. All right, so now that that's red, let's see who wants the ground still. Oh, that's not the real problem, is it? It's the problem of all of this stuff. Okay. That was a big waste. Okay, I'm just overcomplicating this way too much. Who wants a ground? You want a ground. Here, have a ground. Do, 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 do. Bam. All right. We have a ground. We could run snake one through here. Why am I being so pedantic? What is wrong with my brain? Put that there. Okay, now I feel like this has enough clearance. I'm just, I don't, some sort of, I don't know what's going on in my brain. Show ground. This one here. Are you connected? Yeah, you're connected. Okay. Right. All right. Anyone else here want a ground? Ah, you all want grounds, but that's fine. Actually, how do you want to do this? You could go through here. And actually, we could just go ahead and use info. Wait, let's go ahead and have a ground going over to here. Right, because I'm going to need blues to cross in here. But not a whole lot. Yeah, let's go ahead and do that. So what we'll do is have 32 here. Click here. Go there. Host wants a ground. You're going to want a ground all the way through here. And then you can, if you, sir, would like a ground, you can get one there. Go in there. So it's sort of we're not, I may use, okay, so I may change. Okay. Where does it want to get grounds from over here? Do we want to start snaking some grounds? Before I start plopping grounds all over here, let me see what kind of ground action things need over here. Okay, so easiest thing to do here is just pull right off of there. Who else wants a ground? These guys in here, they want grounds. So I might pull, wait a minute. Right. So if you got a ground there, maybe this would be a good spot for you to get some ground action going on too. And I think, yeah. Let's go ahead with that. Or we could do this. I like this. What if we just extend this down for clarity? Now, why are you so complainy, Mr. Thing that for whatever reason keeps complaining? It's just so weird. Okay. Okay, so there's some ground action in here. This guy wants a ground. Let's suppose he comes right down through there. That's one. We'll go down here. If I do this, I maybe be using a lot of red in here. See how that goes. Okay, you want some grounds, but I don't want to cross because there's a signal there. So, whoop. Root air wire. What I'm going to do, so I'm going to move this trace over a bit. Yeah, let's do that. Like that. And now I feel a little more comfortable getting kind of running these thick ground wires. Yeah. Okay, you're coming down this way. And why don't you come in through... Oh, just coming through here. Right. Okay, so we got this going up through here. Show ground. Actually, here's something fun we could do. Let me move this up a bit. I'm going to change. No, I'm not. I thought I had something clever, and it was not clever. All right. So we got a bunch of things that need grounds over here that got grounds. Who else wants grounds? These guys over here want grounds. But I think it will be easier here. We could snake one through here. Especially if... What if we did this? So I'm going to just go ahead and make these guys all red. Red, 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 red. We'll make this guy red. And then just for continuity of concept, I'll make that red too. We'll make this guy red. All right. Show ground. Now I can easily snake Mr. Ground through here. Okay. And now there's a ground. This guy needs a ground, and I'll snake it through here like this. Now I am going to have to do some crisscrossing here, so I might want to actually change this ground. Or no, that's power. Change him to blue. We'll see. We'll see. All right. So this guy here is already blue. Fine. Here, it's going to have to change to red. I'm going back to signals. All right. So it's going to go over here. Has to change to red to cross over here. This guy can be red and cross through here without any problem. This guy... cross it through here. That's kind of ugly. How did that happen? No. Ugliness. Ugliness. How did you get there? Be not so ugly. Actually, do I want to just run this guy up this way? Yeah, that works. A little tight, but it's okay. All right, so those are crossing some blue. See, this needs to come down here. Let's switch back to blue. And see where do you need to go? Okay, so you're coming, are you inputs or outputs? Okay, so you're coming here. Actually, I think I can run this guy here, run this guy here, run this guy here, and this guy here, run this guy here. He needs to not do anything terribly fancy. Okay, it is going to be a little tight, but not terrible. What are you? Oh, you know what? You're the... You know what this is? This is the... This is the control. So, let's see. So it's coming out here. Right, it's coming out there. So one of them's coming over to this guy. One of them is coming up from this guy. One of them is coming from this guy. And so, see, the way I wrote how I did this is it's showing, I think, as the signal flow. Because these are all the things that... Yeah, these are the control. This is the voltage control signals that go into the chip. So the way I've shown this, it's shown the signal flow, right? It's branching out to each of those places, and that's sort of a little mnemonic of trying to figure out what's happening on the board. All right. So let's go here. Here. Sure, like that. Sure, like this. I could switch to red here just to cross that in the most convenient possible fashion. Sure. Or I could have rode around it. Either way would have worked. For continuity's sake of following what's going in here, I'm going to switch this to red. Don't have to do that, but so it's sort of clear if you're looking at that side of the board that these are indeed trying to make a connection. You can see that without having to flip the board over. Let's go back to my default of routing in blue. I said routing in blue. All right. What do you guys want to do? There's a let me look at the long one. How about you? Shows what I want. Okay. So this is let me route the rest of these with blue, and I'll probably do that one in red. Okay. Got those. Could do that a dozen different ways. If I thought about the signal flow more, I might come with something that's more illuminating, but whatever. Right, and now this guy here, let me do the rat's nest. This guy will run with red. We'll run this guy on the other layer. Route airwire. Nope. It's coming out here. Yeah, this works tight, but it's okay. It's okay. I pause there for a second. This one, can we do? Nah. That's fine. Okay, we'll leave it like that. I can't stop tinkering. And again, for continuity, if you're looking at the top of the board and you want to see which via is going where, there we go. All right. Okay, so if that guy's routed, what do we have going down here? Let's switch back to the default of blue. Okay. This guy also wants to, let me move him up a little bit here just to give a little more clearance, just because we can. This one, so there's some crisscrossings here that are going to need to switch to red, like another one. So let's switch to red here, and I'll come up. Actually, okay, that works. And what I'll do is I'll just go part of the way here, run between these pins, come up through here, go there, like that. Info, let's switch this to red for continuity of concept. Okay, now what does this guy want to do? He's going out here. There, something like that. Right. I think this makes sense because this is going in here and then this is bypassing it. This is that weird connection to ground through that resistor and thing. So the signal flow, this sort of indicates what the signal flow is. Though we could get something closer to it. Oh, you know what? Things are getting mixed. That's why this is complicated. See, there's two 15Ks. Or the one of them's the feedback. I don't know. This just looks a little weird to me. So signal flow concept or not, what I want to do is say this is going... Are these inputs or outputs? I think they're inputs. Anyway. Right, they are indeed inputs. So I'm just going to do it like that. All right. Let's see what happens down here. Here I'll use some red because we need to cross over all these grounds. Okay. That one can just go straight there. Right. And this one, for the rest of this, let's go back to blue. No, you know what? These are all coming from the outside. So I think it would be useful to have an indication of these are all on this side of the board if you're looking at all of these at the same time. Okay, let's run the rat's nest command and see how much. Oh, 10 air wires left to go. How exciting is that? Do I know how to party or what? Okay. So this is blue territory right now. So to route things here, let's... sure. Yeah, let's go over. Let's go over here. Oh wait, that's already... Wait, those are already connected. What am I actually connecting here? If I do show this... Oh, I just need to jump the ground down here. Actually, let's do this one first, because this one looks more complicated. Okay. So I got that one. Now, he needs to jump. Okay, I think I'm going to be getting into the ones that are a little bit more complicated. So let's zoom in here. Grab this guy, route airwire. Okay, so we'll go around here. I think that should work. All right. Again, I like to leave a little extra space when I can. So that's routed. Let's see, rats. Okay, 8 air wires left to go. Let's see who wants to connect to what. Okay, so this one's obviously red. I can drop. Okay, I got that guy. Now I want to be able to snake this through without having to do anything too immensely clever. Okay, so I could come up here, go through here, come down here like that. Oh, that's kind of nice. Okay. And then these guys, if I want to show what's going on here. Okay. Actually, since this is an output, let me do this to make that clear. Again, it's a signal flow question. I know that that pin's an output, so that makes the signal flow clear that there's an output going to multiple destinations. Now, obviously, like I don't have the pinout of the SSM memorized, so it's not like I'm being super consistent with that convention. All right, now this is the one that's going to be tricky because. Okay, I may just break down and go ahead and use a via here. Unless... No, because it does... Because it needs to cross this guy. What if... Let me think about that for a second. Okay, what if I did this? I'm going to take this guy and... make him red. Gah. No. There you go. Make him red. Make him red. Make this guy red. Okay. And so I make this guy blue. I'm going to make him blue. Blue. Don't know if this is going to help or not. And then we make this guy blue. This guy blue. This guy blue. This guy blue too. He's going to be blue. Everybody has the blues. And you probably have the blues if for some insane reason you've actually watched this so far. Right, because now, what if I make this blue? Again, there's, I'm sure somebody in the comments, hopefully somebody in the comments will explain how to group this all and change it all at once. Again, sometimes it's easier just to resketch the whole thing. I probably should have done that. Okay. So this one's blue. This one's blue too. Made those all blue. So now I can make this guy be red. And route air wire, yes. And snake it through here. Actually, I want to go over here a bit first. Now I'll snake it through here. Snake it up to there. And let's change this. Let's change this to be red as well for when we're kind of in that situation. All right. Yeah. So it snakes around here. Oh, it's complaining about something here. What are you complaining about? Okay. Zero ground. Okay, so let's just rerun that. I don't know why that was being all... Oh, it's still... It thinks there's a via there or something. That's not supposed to be there. What's going on here? Gah. Okay, not sure what was happening in there. Okay. Whoop. Sorry. 32. Okay, this connects here. And now, oh, it wants to connect that up there, but that's not what I was going to do. So I'm going to snake it around here. Although, you know what? It's perfectly... Let's look at grounds. Okay, we had snaked around that way. And we had to make deal. You know what? I probably didn't have to do all that there. Because I could have just gotten another ground up here anyway. Right. Let's see what that means conceptually. Okay. Show ground. What if I had just gotten the ground from here? So I'm always learning, right? I'm always trying to think of what might be a better arrangement. Okay, so that's ground that snakes up from there. But that means if I do that, I can actually just rip up all of this. Rip up, because I don't need this then. That's what I'm doing. And this all becomes much simpler, less complicated. So this still goes up here through here. And grounds are more grounds. And I have more blue as ground. I have more ground as blue. Right? Show ground. Yeah. So I made that overly complicated. But I think it worked out. Okay. Rats. Who else is left? Oh, there's 3 air wires left. Where are you? So we'll do DRC. We'll do the design rule check. So that... Oh, there's an overlap it's complaining about. Oh! Well, that's a big mess, isn't it? Can't do anything else until we figure out what to do here. Oh, boy. Okay. Let's just move this guy down. And then this should still be fine. And what we'll do is say... Oh, yeah. Okay. We need to think about this more. Because if that went up there... Let's see, if I make this red... What if... No, because that will cross through there. That would be a big problem. Okay. Let's show ground again. there's not an easy way to snake that through. Oh, there's several places to do it. Oh, you know what? Let's do this. So I'm going to rip up. Oh, this is actually not that terribly tricky. What we'll do is we'll say okay. Do I want to just go ahead and put in vias there? Nah, because I like, let me think for a second. Oh, no, because it's got to cross this no matter what. And this has to come over here. Right. Okay, so let me just rip up this ground. No, not that. Okay. And let's just say, oh, there's one right up there. But no, he needs to cross that other one. Really do not want to make this overly complicated. Because if we can make this guy red, that would work. I'm being way overly pedantic here. Show ground. Because there's places there, it's not hard to do if I just go ahead and use a smaller trace. Or what if... No, because it's going to have to cross that regardless, either way. All right. So there are things to do. I'm just going ahead and well, let's say this is 32. Go ahead and like that, and we'll just switch to a, because it's going to be, there we go. We'll snake it through this way. And because we can, we'll go ahead. It's pulling out of this side, so we'll pull it down like that. All right. Do I like that? I like that. That's not that far. Yeah, how about that? All right, so it goes do, 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 do. And then with 32, this is probably not the best star grounding scheme ever. But I think we've got 3 air wires. Okay, first of all, not complain about that anymore. Oh, okay. What's happening over here? Did I miss a ground? Show ground. Oh, I did. I missed a ground. But that's easy enough to solve. All right. 2 air wires. All right, so I'm going to clear out. This is just a connection. Okay. I'll go there, sure. And there's one more air wire. Wait a minute. Okay, so what do you want to do? Oh, you guys want to be connected. Okay. We need to cross through here. So let's just go ahead and use the top layer. And, it's going to want to be obnoxious about this, isn't it? I'm going to rip up this one just to make this easy to run. So Eagle's so persnickety about where. Okay, so I'll put that here. Crosses over to this side. And we'll say this one's coming up like here. And sure. Just going through the pot. So, how about that? Okay. Don't remember what the signal flow is here. All right. And I think that is all of the... That's all of their wires. We've routed everything. And it's passing usual design rule checks. The next thing to do would be to clean up the silk screen. And let's do that on another day.